Hello students, dear friends, good morning. This is Professor Dr. Moina from Dr. Amekazi Institute of Chemistry, University of St. Jamshoro. I'm here today to discuss with you a new instrument called XRD. It's not a new actually, it's a very, you can say, old instrument. It's been used since many years by different people, different scientists, different researchers all over around the world. But I thought that my students, they must know the different instrumentation techniques, and this is one of the very powerful instrumental technique, you can say, or you can say it's a tool for simply characterizing arrangement of atoms in crystals and distances between crystal faces, right? And it can also measure, you can say, the crystal structure of the powder or thin films or thin film materials, right? So what it does, this XRD stands for, this is simply X-ray diffraction, right? So it has something to do with X-rays. Now what are X-rays? I hope everyone knows what are X-rays, but still you need to learn what are X-rays. So now basically the instrument, it's a great instrument, right? The sample to be analyzed is placed in the center of that instrument, right? And is shined or hit by an X-ray beam, a very strong X-ray beam. The X-rays are produced in an evacuated tube. There is an evacuated tube where these X-rays are basically produced, right? So the X-ray tube and the detector, they moves in a, you can say, a contemporized manner, right, or a synchronized manner, and they are hit by, and as they hit the sample, they are diffracted to the detector. So the signals produced by the sample are simply presented via graph, right? And you will see number of spikes in them, some lower ones, some very stronger spikes, right? And these spikes are related to the atomic structure of the molecules of the samples. That basically it simply tells that. Now the graph is plotted between intensity versus 2 theta. Now what is intensity? What is 2 theta? I will explain you later on. Now the crystalline sample and the crystal is made up of, you can say, systematic or well-ordered positioning of atoms, right? A regular well-ordered positioning of atoms. And we all know that atom has a nucleus and it is surrounded by a number of electrons that are revolving around it. There is an electronic cloud, right? So now here you can say that basically what the story regarding the X-rays starts. Now the X-rays, they exit the tube and are incident on the sample where they are diffracted. This is simply the, you can say, happening here, the diffraction, right? So they are diffracted here. Now the beam passes simply through a slit, right, which determines the angular width of the beam. There is an angular width that the beam carries, right? While the slit gets more energy that have wider peaks, smaller slits as compared to the wider ones gets less, or you can say smaller energy, but with a very you can say enormous or better resolution. A better resolution is always achieved, right? The beam also passes through the nickel filter. The nickel filters are also there, right? So this is how this whole process it goes on. Energy before the diffracted beam enters the detector. X-rays at an angle theta are, you can say, reflected from the internal crystal plane separated by distance d. Now here comes, you can say, an expression called n lambda equals to 2d sine theta. This is something to do with the Bragg's law. What is a Bragg's law? This is again a question which I'm going to solve soon for you people, right? So the Bragg's diffraction results from a constructive way of interference, you can say, when the quantity 2d sine theta is, like, you can see that there is an interplanar spacing between the atoms, and that interplanar spacing is always represented by d, right? X-rays are high energy light with a retreat unit called lambda, the wavelength, right? So this is a special interference effect, and diffraction is used to calculate the distance between different atoms. Now interference happens in two ways, right? And when X-rays interact with one another, and if the two waves are in the same phase, that is, you can say they are interfering constructively, and their amplitude will increase with the increase in the intensity. Whereas if the two waves are in the two different phases, right, that is positive and the negative, their amplitude will cancel out each other, resulting with a decrease in the intensity. And you can say this is simply, you will call it a destructive interference, right? This can be shown here on the paper. I can show it to you right now. Now here in this figure, you can simply see here interference. It's simply divided into the two ways, that is constructive and destructive interferences, right? Now here you can see the behavior of the wave. If the two waves, you can say simply they are in the same phase, they will interfere constructively and resulting increase in amplitude. What will happen, and with the resulting into the increase in their intensity, their intensity will also increase, right? Whereas here in this phase, you can say the wave behavior, you can say that the positive and negative both phases are parallel to each other. So the positive phase is parallel to the negative phase, and resulting, what will happen, the amplitude will cancel out and intensity will decrease. So these are the two waves are in two different phases. Now here you can see the two different phases, that is the positive and the negative one, and this simply implies to the destructive phase, destructive type of interference. So this is the basic difference between the constructive and the destructive interferences, right? Only the difference lies between the phases, that is the difference in their phases. Atom faces an X-ray beam, right? The energy is absorbed by the electrons, right? And this energy is not enough for an electron to be free. So the process of elastic scattering takes place. And what is that process? It's simply, you can say it is the energy is in the form of an new X-ray as the original energy, right? So now you know that the crystal has an ordered arrangement of atoms forming different planes, separating from each other by an interspacing or you can say, or well-defined distances denoted by D, right? There's an interspacing between them, and that interspacing between those atoms, or you can say they have it is denoted by D, as I just shown you on the paper. So when these planes are hit by an X-ray beam, these are scattered by these regular spaced atoms, right? And strong amplification of the signal occurs here and at specific angles, right? And with the scattered waves constructively forming constructive interferencing, causing constructive interferencing, and called the diffraction, right? Now here I will tell you something about 2 theta. That is the angle. You will have a graph that you are going to be seen in when the sample is exposed to these X-rays. The detector shows you a graph that is plotted between intensity and 2 theta. Now what is 2 theta? 2 theta is simply an angle between the incident and the scattered beam. Hello students, so today I have explained you a brief review. I've given you a brief review about XRD, that is X-ray diffraction, and as this was something new to you people, so I thought that I must share my experiences of XRD with my students and my viewers. So today you have come to know what is X-ray, what is XRD initially, and how this instrument works, how the sample is put inside it, and what happens after that, how the X-ray hits the sample, how you find a graph that is plotted between 2 theta and intensity, and what are the planes that are formed, and you will see the spikes there in the graph. And what are those spikes? The number of planes that are shown there, they are the number of spikes you show there, they are actually the number of planes, right? So and you have come to know about the interference, that what type of interference can be there. It could be constructive when the waves are there, the interferences there. So there are basically two types of interference that occurs, that is the constructive and the destructive ones, right? And I told you and I explained you the difference between the constructive and the destructive one, right? So, and I've shown you different explained you what is 2 theta, that is the angle between, you can simply say, the incident and the scattered beam, right? So you've come to know a lot of things new as which you have never, I think, heard before. So I thought I must share these views, and I took all these views from the Brooker Corporation. I took the references. I can quote this from the Brooker Corporation, and it was something very interesting to find about this short video that I saw. It was beautiful, and it was well explained from the Brooker company. So I thought I must share the reference as well, that from where I took all these ideas, and from some other websites also I took these ideas, because whenever we have to explain something to somebody, we need to look into the books and the literature. So nowadays we look into the other scientists that are that have gone through all these processes, and now we are making it more easier for our viewers, our students, to follow in our language, in our way, so that they will be able to operate this instrument and easily see its you can say follow its different its steps to operate the instrument. So I hope you find this video interesting, and you will gain a lot of knowledge from this XRD part 1. I will call it part 1 because inshallah I'm going to continue with it, and I'm going to explain you few more very interesting things about XRD, which I have made my students, my research students, learn, and it would be helpful for my research students also. So I would like to ask them to go through my videos for their further knowledge, and for to be competent enough to answer any examiner about the instrumentation techniques they have gone through right now, right? So thank you very much. Hope to see you again in my next video. Hope you will like it, and you will share it with your friends, or you will simply memorize it. You will again watch it again and again, and you will see what knowledge you gained about all that. So thank you very much.